Good day, good day, good day. Welcome back to our another session on trigonometry 2D, 3D. And on this session, we are going to focus on the sine rule. So on the sine rule, we are going to prove the sine rule as well as show you how to use the sine rule. So how does the sine rule work? The sine rule works when you are maybe trying to find an angle and you are having one more angle as well as two sides, or if you're trying to find a side and you're having another side and two angles. So that's how the sine rule works. So it's either you're trying to find an angle or you're trying to find a side, right? So how do you prove the sine rule now? So proving the sine rule, it is simple. As I already stated that in these sessions we are going to deal with triangles that are not right-angled triangles. So in this session we are trying to prove that the sine of this angle, angle A over side A. We already explained these sides, how you can manage to find this side. So this angle A will be opposite to the side small letter a, and angle B will be opposite to this side with small letter b, right? So here we want to prove that sine of this angle over this side is equivalent to sine of this angle over the small letter b. So how do you prove that? So first thing first, I said when we're trying to prove, we start by constructing. So we are going to construct. So what do you construct? We are going to construct this other angle that we are not using, right? So we are going to construct from C to small letter c, but it must be perpendicular to that. So let's do our construction. So this must be perpendicular to that. So we are going to construct a perpendicular line from angle C to side C, like that. So now how do you prove that now? So we are going to prove in this triangle that we constructed and this other triangle that we constructed as well, right? So let's see. So maybe let's call this H, this constructed line, let's call it line H, right? So let's see. We know that from this triangle, we know that the sine of angle A, you can see that if you're having this angle A, the sine of this angle will be equal to opposite over the hypotenuse. So this is equivalent to H over B, and which, if we are trying to make H the subject of the formula, it means that our H will be equivalent to B multiplied by the sine of A, and you can call that maybe our equation 1, right? So let's see what else do we need. Again, if we are trying to use this other triangle, we can see that the sine of this angle here, so the sine of angle B will be equivalent to the opposite over the hypotenuse, right? So here don't forget that once this line is perpendicular, it means that these both angles will be 90 degrees. So sine of angle B will be equivalent to H over our small letter a, which if you're trying to make H substitute the formula, it means that our H will be equivalent to A multiplied by the sine of angle B, and you can call that our equation 2, like that. So now here we can see that we're having two equations that are having the same subject of the formula, so we can equate these two equations. So equation 2 is equals to equation 1, right? So equation 1 is saying b multiplied by sine of a is equivalent to a multiplied by the sine of b, right? So now we can divide both sides. So we are going to divide both sides by a b. So if we divide both sides by a b, it means that here if we divide by a b, and also here if we divide by a b, it means that b here will cancel b, and this side a will cancel a, which leaves us with this now. So here we'll be left with sine of angle A over A will be equivalent to sine of angle B all over B. As simple as that. So now we've proved that. So how do you use this equation? So just notice that this will be the same also as sine of A over A will be equivalent to sine of B over B, as well as sine of C over C. So it means that no matter which side you are having and angles that you are having, you can always use this to find the unknown side or the unknown angle. And if you want, you can also invert this, or you can reciprocate this, which means that our A over our sine of A will be equivalent to our B over the sine of B, as well as our C over our sine of C. No matter how you use it, it will always work. So this is the sine rule. It will help us to solve triangles that are not right-angled triangles. And they also work on the right-angled triangles, but we prefer much on the right-angled triangles to use just the ratios, right? So let's just try to solve some questions using this. Let's see how it goes. So before us, we're having a couple of questions. So let's see how we can solve them one by one. Right. So determine the values of the unknown in each case. So let's start with number A. So how many unknowns do we have in number A? We're having 3 unknowns. We need this angle beta, we need angle theta, and we also need the value of x, right? So let's first maybe start by finding angle theta, right? So we can see that we're having A, so this will be our side A there, and then this is our C, then this is our side C, and this is our B, and this will be our side B. So now trying to find this angle, we can say that sine of angle C, which is theta, so sine of theta all over the opposite side, which is C, which is 10, will be equivalent to, maybe let's use, what do we have? We also have sine 70, and we have 13 that side. So this will be sine of 70 over 13. So now making this subject of the formula, it means that our sine of theta will be equivalent to 10 multiplied by sine of 70 all over 13, which means that our theta now becomes the second function of sine of 10 multiplied by sine of 70 all over 13, like that, which makes our theta now being equivalent to 46.29 degrees, like that. So here we found the value of theta. Let's move maybe to the value of beta. So as always, you know that this is a triangle, and you know that each and every triangle has 180 degrees. So we can say that our beta plus our 70 plus our 46.29 will be equivalent to 180 degrees. The reason being sum of angles in a triangle, right? So which means our beta will be equivalent to 180 minus 70 plus 46.29, which makes our beta being equivalent to 63.71 degrees. So now we know the value of beta. So once we know the value of beta, now it means that we can be able to calculate the value of x, since our x is opposite to this angle beta. There was no way we could find the x without knowing the value of beta, right? So now it will mean that our x over the sine of beta, which our beta is that, so over sine 63.71 will be equivalent. We can choose any side, since any side is having the angle of its own, right? So it can be equivalent to 13 over the sine of 70, right? So now this will mean that our x will be equivalent to, so we can multiply, so this will be sine 63.71 multiplied by 13 all over sine of 70. So which makes our x equivalent to 12.40 units. Just like that, as simple as that. So now let's move to our next question. So on this question, we need the value of theta, we need the value of y, and we also need the value of x. So we need 1, 2, and 3, right? So we can start with any value. We can see that in this triangle already we're having 2 angles, so we can find the value of theta without any complications. So what do we know? We know that our theta plus 114 plus 22 is equivalent to 180 degrees, which makes our theta being equivalent to 180 minus 114 plus 22. So our theta becomes 44 degrees, like that. And then we can move maybe to find the value of x. So x, you can see that it is opposite to this angle, right? And you can see that 7 is opposite to that angle 22. So it means that we can say that our x over sine 114 is equivalent to our 7 over the sine of 22, which makes our x being equivalent to 7 multiplied by sine of 114 all over sine of 22, which our x now becomes 17.07 units. And lastly, we can move to the value of y. So you can see that our y is opposite to this angle, so it means that our y over sine of theta, which theta is 44, is equivalent to our 7 over sine of 22, which makes our y being equals to 7 multiplied by sine of 44 all over sine of 22, which makes our y being equal to 12.98 units, just like that. Let's move to our next question. Let's see how it goes. Okay, let's take a look at this one now. So this is a right angle triangle. We can see that this is 90 degrees and it is opposite to 15, and also our 12 is opposite to theta there. So this will be simple. It's either you can use the ratio straightforward, or you can use also the sine rule. It's also still the same. So we can say our sine of theta over our 12 is equivalent to sine of 90 over our 15. So we can multiply both sides by 12. So it means that our sine of theta will be equivalent to 12 multiplied by sine of 90 over 15, which makes our theta being the second function of sine. What's happening now? Okay, 12 times sine of 90 all over our 15, which makes our theta being equivalent to 53.13 degrees. So now on this last question, let's see what's happening. We're trying to find x. So x is opposite to this angle of ours, angle 135, and this 24, we can see that we are not given any value that it is opposite to, but we know that this angle is opposite to our 16. So it means that we first need to find this angle so that we have something to relate to, right? But already we're having two angles in this triangle, so it means that we can find the value of this angle. So we know that our angle A plus 135 plus 24 will be equivalent to 180, which makes our A being equivalent to 180 minus 135 plus 24. Then it will mean that our angle A will be equivalent to 21 degrees, like that. So it means that now we can find the value of x. So it means that our x over sine of 135 will be equivalent to 16 over sine of 21. So our x now will be equivalent to 16 multiplied by sine 135 all over sine 21, which makes our x equivalent to 31.57 units. So this is 31. So if you have gained something, please show us by liking, commenting, and also subscribing. Don't forget to subscribe. So it means that on our next session, we'll be dealing with the cosine rule. Have a lovely day.